So let's start. And again, today is going to be covering more good coding practices. So today we are covering what is version control. And I imagine the three of you guys that are here aren't very familiar with version control, right? So I will go straight into the slides rather than asking you what version control is. So here is a set of slides that I have. And version control is basically a software tool that helps teams manage changes to code over time. So this helps you with things like reverting or recalling versions of a code base. So if you made a change and you pushed it to the repository, but you accidentally broke something, using version control, you can go back to the version that was working that did not have your change. Another reason for this might be that there is some feature that was in the code base before, but got removed for whatever reason, but then you need to access it again. You can go back to that old version and use it. This also keeps a record of changes. Every single change that is pushed to the repository is kept as a record, and it helps you track who did what in the source code. So who was the person on the team that's made a mistake, or who was the person on the team that's made this feature X times faster. So it helps keep track of all of that. Or even just who was the person that made this, because I'm working on this now and I have questions for them because I don't understand it fully. There are two different types of version control systems. There's centralized, where it's just a single repository and all operations are done with reference to this central repository. The more common system is a distributed version control system, where there's not just a single repository, but there's multiple, and all operations can be done from any developer repository. And the most popular version control system is Git. So Git is not only used by GitHub, but also other software as well. So why do we need version control systems? It allows for easy modification because we can make continuous process of modifying programs easier. It allows for this collaboration, right? Rather than manually figuring out these merging changes or having conflicts when you're working on the same document, the version control system makes sure that when you are adding your change, it forces you to fix any conflicts with any other code that was added since the last time you checked out the main repository. And again, you can recover an earlier version, and we talked about many different reasons at the beginning why you would want to do that. And it also offers this backup. So rather than only having one version of your code on your laptop and then your laptop dies, then you have to rewrite your code. If you have version control, there is another version of your code, whatever your last commit or push was, somewhere else. Maybe it's on a different computer that you have. Maybe it's on a centralized server like GitHub or Bitbuckets. There are many different services that you can use. There's GitLabs too. So this is an example of using a version control system. So the assumption is that we have a small team, just 2 people, and they're using version control repository that holds the master or original copy of the project. So if you're going to make some changes, the first thing that you'd need to do is check out the code from the repository. So then that gives you a local copy. So the 2 teammates get a local copy that check out the code. And then they individually make their changes. So this person makes their changes, this person makes their changes. And then what happens after that is, say the first person commits their changes to the repository and the changes are merged with the master copy. And no one else has committed any changes to the repository since they both check them out. So there is no conflict because there was nothing else added since the last time. But now, what happens when the second person wants to now make their commits to the repository? There have been changes to the main repository that this person does not have on their local copy, right? So if they have edited different areas in the file, there's no conflict. And the second person's changes will just be committed successfully. But if they have edited the same areas in the same files, then there's a conflict. And this repository will notify the second user of these conflicting lines. They'll say this was added by someone else. This is what you added. You need to fix this conflict. Which one should be used / how can they be merged successfully where both changes are needed? And then once the second person resolves that conflict and updates the local copy, then so you're going to update it. So you first get all the conflicts, right? Then you make updates to merge the changes from the first person with the changes that you are making as the second person. And then once you have resolved all those conflicts, you can commit the changes to the repository. So this is kind of the main process of using version control and working as a team on the same repository. Does that make sense? And then one kind of good practice to do when you're working on a team on a version controlled repository is before you do anything, like start making changes to your local copy, you first update your local copy, see if there were any changes made. That's the last time that you made any commits. Because if you don't do that, and there were changes, then you're almost surely going to have to deal with merging changes. But if you update, make changes, the chances of, especially in a smaller group, having to merge and someone else has just made changes is lower. Right? And it might be important to know what was worked on, right? Because if someone else has already resolved a bug or implemented a feature, then you don't need to, right? All right, so here are the main operations in the Git version control system. So you have your Git repository. You're going to check out the project, and that's when everything is now in the working directory. And then you make your changes. So you implement your feature, fix your bug, whatever it is. Then you stage the files. You say, I want to add this file, and this file that I make changes, and I'm done working on them. I've made this small change. And then after you've staged the files, you can commit the files to the local repository. And then if you're using a centralized thing like GitHub as well, then after you commit, you might want to push, which is pushing your local changes to the central repository that is on some other computer. And then one thing that you should always do is on this commit, there's a flag that you can use, -m. You should write a message that is, what exactly was this change that I made? So was it fixed this bug, implemented this feature, and this staging and committing should be done very frequently, because when you commit, you should only be committing one thing. Like I made this one change. Because if you are going to say, I implemented this feature and this feature and this feature and this feature and this feature, then it kind of defeats somewhat the purpose of using version control in the first place. Because now say you make that commit and then someone else finds, oh, there's a problem that has occurred since this push to the repository. But on this commit, it says they did like 10 things. What of these 10 things caused this problem? But if you commit one thing and you make one change, and then it causes a problem, you know exactly where to start looking. So one thing to note is that Git is not GitHub. So Git is it's the commands that are used for version control. GitHub is a centralized version control system. Right, so this is like a server where the central repository lays. We've all heard of GitHub, right? So it is a website for hosting projects that use Git. And again, Git is a version control system that is making it easier to track changes. And then some common commands is you can use git init. This is going to make the current working directory now a local Git repository. And then if you already have an existing repository on some centralized server like GitHub, you can check it out by using git clone and then the URL to that GitHub directory, that GitHub project. And then by git cloning, it creates a local version that is a Git repository. But if you do this first, then all you have is your local repository. This does not create anything on GitHub. If you wanted to then make sure that it goes into something like GitHub, you have to then push it to GitHub. Another thing is git status. It's just going to print some basic information, like what files have you modified since your last commit, or what are some files that you've added to the staging area, but you haven't committed yet, or things like that. And then the way that you add things to the staging area, this step from working directory to the staging area, is with the command git add. So if you do git add and then file name, that adds it to the staging area. So are these basic commands clear to you guys? Is it clear what these commands do? Of course, you're going to have to play with them and actually do them to kind of cement it in your memory, what they do. But for now, as it's fresh in your mind, there's no question. Okay. So this is just going to go over adding a new file to a Git repository. So you first create the new file, right? So this is going to be called newfile.txt. If you do git status, it'll say, hey, there's this new file in this repository that I have no idea about. It's untracked. It has no history. And then it's also saying that there was nothing added. So you can use git add if you want to track it. So then the first step, right, is to stage it. So we're going to do git add new file.txt. And that adds this new file that I've created to the staging area. And again, we can use git status. It says there are changes that have yet to be committed. And here it is. It's a new file called newfile.txt. And then if you wanted to remove it, you can use git rm cache new file, and then it no longer exists as a tracked file. So if you added it by accident, you can do this. Make sense? But if it was intentional, and now you want to do the next step, which is commit it to the local repository, then you can do git commit, and then the -m is the message that I was talking about earlier. Here's the message, added my first text file, right? It should be one small change, very short message, right? And then it adds the file to the master branch. It tells you exactly what was changed. It was one file that is changed, one insertion to that file. So maybe this file only has one line, right? And this is the added file. And then it also gives you this hex code. This hex code is a unique code in the repository that now allows us to go back to this exact change whenever we want. This is one of the key features of the version control system, because we have a version of every single commit and push that we make. Make sense? You can also do this command, like these two commands all together. So git commit -a adds it to the staging area, and then -m is the message for the commits. So it's going to add the modified files to the staging area and commit them at the same time. So if you try and run commit without adding first, it will give you an error. That's all this slide was saying. Because the steps are first, stage it with add, then commit. But you can do them both at the same time with this -a -n. Okay, some other commands on Git. So git diff is going to take two files and just outputs the differences between the two files. So it's very similar to the diff command in Unix, which also takes in two files and then shows you the differences. So this command is going to help you when you are doing the merging of conflicts. And you can also git help and then any command. So git help diff, git help add, git help commit, git help rm. If you're not sure, it'll give you a kind of overview, a short summary of what that command is, what are the different flags for that command. And you can also do it this way. So git and then the command --help. And the other way that you can get information is with the man command. So this man command is short for manual. So manual, git, add, right? These three commands are most likely going to be giving you the same information. They might be slightly different, but overall it is just, what is this command? How do you use it? What are the flags? And these are the three different ways that you can get that information. And then here are some other resources about Git. And that's all that I have for version control. But if you remember anything from this, it should be this process here. How to use version control system as a team, and what is the process, right? You both check out, you make your changes, you try and commit or push, but if there was already changes since the last time you checked it out, then you have to merge them. Make sense? And then why do we do this? Because of all of these reasons. But mainly, it's going to be collaboration. It gets much, much more difficult when you have larger and larger teams to collaborate. If you only have one single file, like one single repository that everyone is trying to edit at the same time. Okay. So one other thing that is not quite covered on these slides is if you are using a centralized thing like GitHub, after you do this local commit, you would do the global kind of commits is what you maybe might call it, where you're pushing to GitHub, which is the one centralized repository that is supposed to have all the changes as well. So if you just commit to your local repository, that change is not reflected on GitHub. If you want it reflected on GitHub, you have to push that change. And it's just git push. And the other thing, if you're using GitHub like that, in order to check out anything from the centralized version, you check it out by doing git pull. So pull gets changes from GitHub, push pushes your changes to GitHub. So it's just 2 additional steps. And just like I mentioned, that is common practice to always check out your code before you start. It's common practice if you're using GitHub or something like that to pull first. And there are other features like branches, but I'm not going to cover that. It's more of an advanced topic that you'll learn about as you use GitHub more and more. So it all makes sense? Like why it exists? Maybe not exactly how do I do this right now, but you can go back to the lecture, look at it, and then with practice of doing this with all of your future projects, you will become better and better at it. Okay. So that is what I have for today.